Welcome dear students to our lecture series on Transportation Engineering 2, and today we are going to discuss correction to basic runway length, which is a very important topic of airport engineering from exam point of view. In today's lecture we are going to talk about correction to basic runway length, and the three corrections which we need to apply to basic runway length are correction for elevation, correction for temperature and correction for gradient. The first two correction, which is correction for elevation and correction for temperature, is given by ICAO, that is International Civil Aviation Organization, and correction third, which is correction for gradient, is given by FAA, that is Federal Aviation Administration. And remember one thing, that all these three corrections are sequential corrections, means you have to apply the correction for elevation first, then correction for temperature second, and correction for gradient third. All these corrections are sequential, and these corrections are always applied to basic runway length. So whatever increment will be there, that increment will be always to the basic runway length only. Is it clear? Now correction for gradient. So ICAO's this correction is given by Federal Aviation Administration, and it says that you must increase your basic runway length at a rate of 20% for every 1% of effective gradient. So whenever we have to apply the correction for gradient, we must calculate the effective gradient. What is the effective gradient? The maximum point, the highest point minus the lowest point divided by the length of runway. So for that, let's have a simple problem, then we'll be doing the problem which are typical one. So let's start with simple problem. Corrected length of an airport runway after applying correction for elevation and temperature is 2860 meter. So whatever value I am having over here, that is 2860, this value is after applying correction for temperature and elevation. What is saying? Calculate corrected length after applying correction for gradient if effective gradient is 0.69%. So what we know over here, that we must increase our basic runway length by 20% for every 1% of effective gradient. So for 0.69%, how much should be correction? Let's look over here. So correction will be always applied to the basic runway length. Here my basic runway length after temperature and elevation correction is 2860. 20 divided by 100 at the rate of 20%, multiply by 0.69. So I'm getting a value around 394.68 meter. If I will add this value to my basic runway length, which I got after elevation and temperature correction, I will get the corrected length after gradient correction, and it is coming around 3252.68 meter. So now this value is going to be my basic runway length after applying all the three corrections. In the given question, two corrections were already applied, so we are not going to apply those corrections. Only the correction for gradient was asked to us, so we have find out only that value. Now come to problem, which is a typical problem. So what they are saying, calculate effective gradient for given data if length of runway is 3400 meter and elevation is 360 meter. So your airport site is located at an elevation of 360 meter. What he is asking, just calculate effective gradient only. You don't have to do anything extra. You just need to calculate effective gradient. And what is the given data? The data is given in this form. That is chainage. It means that for first 300 meter, your gradient is +1, means you are having ascending gradient up to 300 meter. Then you are having 300 to 1200, a descending gradient of 0.5%. Then for 1200 to 1800, you are having a ascending gradient of 0.5%. Then for 1800 to 2400, you are having a descending gradient of 0.6%. And again from 2400 to 3500, you are having ascending gradient of 0.5%. So let's first of all calculate the rise and fall. So how I have calculated it? 300 multiplied by 1, that is 1. percent, so 1 divided by 100. So 300 multiplied by 1 divided by 100, I will get a value of 3. Second, I have a length of 300 to 1200 means 900 meter. 900 multiplied by 0.5 divided by 100, I will get a value of 4.5. But my gradient is negative, that's why I have put the negative sign over here. In third case, it is 600 because 1200 to 1800, how much length will be there? It would be 600 meter. So 600 meter multiplied by 0.5 divided by 100, I will get a value around 3. So by doing this, I got all the value. Now I got the cumulative correction. Right. So how much is the cumulative rise or fall? So first 300 meters. So now come to this figure only. So you will come to know what we have done. So let's start with the 0. And I have considered my RL is 0. You can also write 360 over here as in the given in the question. But if you are going with 0, there is no problem. So at 0 meter, my elevation is 0. Now at 300 meter, what I come to know that I have a rise of 3 meter. Because for first 300 meter, my gradient is plus 1. So what I have done, I have a rise of plus 3. So this is my total rise. Is it clear? Up to 300 meter. Now what about 1200 meter? When I am going to 1200 meter, what I come to know that I am having a descending gradient, and when I will reach to 1200 meter, my value is 4.5. So I am having a total descending slope of 4.5. So here my ascending, here my value was 3, here my value is minus 4.5. So at 1200 meter, I am having a descending slope of, so here descending slope of 1.50 meter. Is it clear? So this is the value. Now what about 1200 to 1800? So when I am going from 1200 to 1800, I am having ascending slope of 3. So again from here to here, I got a positive 3. So it will become plus 1.5 over here. So when I reached to 1800 meter, I was having a rise of 1.50. Then again from 1800 to 2400, I am having a descending slope of 3.36. So 1.50 is my rise, but when I will reach to 2400, I will get a negative of, or say descending value of 3.60. So when I will add minus 3.60 to plus 1.50, I am getting a value around 2.10. So when I will reach to 2400 meter, what I will get? I will be having a descending gradient of 2.10 meter. And in the end, from 2400 to 3500, I am having a total rise of 5.5 meters. So from 2.10 negative, I will get a rise of 5.5 meter. And when I will when I will reach to 3500, I am getting total rise of 3.40. Is it clear? So from here, what you can see, my maximum value is 3.40 positive and my minimum value is 2.10 negative. So how to get the effective gradient? Maximum minus minimum with respect to sign. So here my maximum is 3.40 minus minimum is 2.10 divided by 3500, which is the length, and we want in terms of percentage, so whatever value we are having, multiply by 100. So the effective gradient for the given data is coming around 0.157%. You can repeat this exercise, you will come to know what you have to do. Let's have one more problem to calculate effective gradient. So in this problem, what we are having, calculate effective gradient for a given data if length of runway is 3400. Sorry, the data is wrong. Just look at this table. So the chainage is 0 to 300, 300 to 600, 600 to 1200, and 1200 to 1500. So when your gradient is plus 1, sorry, when you are for 0 to 300 meter, your gradient is plus 1. So what you will get? You will get a rise of 3 meter. Then again for next 300 meter, you are having a negative gradient. So you will get a fall of negative 3 meter, or say fall of 3 meter. Then for next 600 meter, you are having ascending gradient of 1.2. So you will be having a total rise of 7.20%. And for last 300 meter, you are having ascending slope of 0.20. So the total rise will be 0.60. Now come to the cumulative rise or fall. So when you are at 0, your RL is 0. Sorry. So when you reach to 300 meter, what you will find that your elevation is 150. 3 meters. Suppose we have considered RL as 100 meter. Then when you are at 600 meter, what you will find that you got again minus 3. So when you reach to 300, you were having the rise of 300, sorry, rise of 3 meter. But when you reach to 600 meter, you were having a fall of 3 meter. So 103 minus 3, you will get a elevation of 100 meter, which is at 600 meter. Now when you have reached to 1200 meter, you got a rise of 7.20. So over this course of 600 meter, you are having total rise of 7.20. So from 100, which is at 600 meter, you get an elevation of 107.20 meter. At this point, this is the total elevation. Now for last 300 meter, you are having ascending slope of 0.60. So you will add 0.60 to the 107.20. You will get a value of 107.80. So this is your final value. So if you will see it, look at the maximum value, your maximum value is 107 and your minimum value is 100. So how to get maximum minus minimum divided by length of runway. So here the length is 1500, multiply by 100, I got a value around 0.520%. So by this way, you can simply calculate the effective gradient, and by using this value, you can simply calculate the correction for effective gradient. Remember, in this case, we didn't use minus with 100. Why? Because 100 is the minimum value. In previous case, my 2.0 with negative sign was my maximum value. So there is a difference. Look at this problem. It is minus 2.10. That our maximum is 3.40 and minus minimum. Minimum is 2.10. So the total difference between the maximum and minimum is around 5.5 meter, and divided by 3500, multiply by 100, you got a correction effective gradient around 0.157%. Is it clear? Hope you have understand everything. If you are further having any doubt or query, you can post me. Thank you.